The idea of this lesson is an introduction to definite integration. Okay, this starts with just a basic definition of definite integration. Okay, used predominantly to find the area underneath a curve to represent some physical quantity. Okay, in future lessons, we'll look at what these quantities are. Okay, it could be a distance, could be a total energy usage. Okay, basically anything that would normally multiply, we'll be finding areas under curves. Okay, so just for an example of how this works, okay, for example, take the function y equals x, the straight line. What would be the area under the curve? So underneath here and above the x-axis. So we're looking at this shaded region between 0 and 1. Okay, so between 0 and 1, this triangle. Hopefully you remember your area of triangle formula. Okay, base times perpendicular height divided by 2. I should be able to find the area of this triangle. Pretty straightforward. Okay, the base is 1, height is 1, divided by 2. I'll get an area of half a unit squared. Okay, whatever we're calling these 1 by 1 units. Okay, is there another way to do this using integration? Yes, there is. Okay, I can use this symbol. Okay, the integral from 0 to 1. Okay, so remember this is from 0 to 1 of the equation. Okay, x with respect to x. So what we'll do to this definite integration is we'll integrate. So integrating x, rate increase the power by 1 and divide by that new power. Okay, indefinite integration, we don't need plus c because it'll cancel out. We'll see this in the future. Put square brackets around it and put these bounds on either side. So I've integrated it. Still want to know what this area is between 0 and 1. Okay, so what I need to do now is substitute in the 1 here, 1 squared on 2, and then subtract the 0 substituted in there, 0 squared on 2. And if I evaluate this in my calculator, I'll end up with just a half. Okay, exactly like I did when I just found the area of the triangle. Okay, there's heaps of theory you can look in for how this works. Okay, but for our purposes, we're happy that this definite integration process will help us find areas under the curves. Okay, so in general, if I'm trying to integrate between a and b of some function, okay, I'll put the integral in square brackets. Okay, for capital F is the integral of f. Okay, and then I'll evaluate that at b, subtract the thing evaluated at a. That's the general idea. Okay, so we can also find the area under curves that we wouldn't be able to ordinarily. Okay, if I'm trying to find the area underneath the curve y equals x squared, this is x squared between 0 and 1, okay, between these 2 points, I can find that area just using integration. I couldn't find it any other way. This shape isn't a semicircle or a quarter of a circle. The only way I have is integration. Okay, so I'm after the integral from 0 to 1 of x squared with respect to x. Okay, so to find this, I'll integrate, increase the power by 1, divided by that increased power between 0 and 1. Evaluate this at 1, subtract this thing evaluated at 0. End up with an area of 1/3. Okay, so from here, have we got these problems? Okay, that was essentially from last term. What we looked at this term is just a quick review of integration. Okay, so we just looked at 3 integration problems. They shouldn't take us too much thought power to solve. Okay, integrating between 1 and 4 of x squared. I'll integrate, increase the power by 1, divided by that new power between 1 and 4. So I'll evaluate it at 4 minus the thing evaluated at 1. And I'll end up with a thing that ends up as 21. I can check these on my calculator. Okay, make sure I've got it set up correctly, yeah. So I'll go options, I want to do some calculus. I want the integral of x squared between 1 and 4. Okay, I get 21. Yeah, that's how I can check, and when I'm doing my assignments or modeling problem solving questions, I'm allowed to use my graphics calculator here. Okay, question 2, you need to remember some of our integration techniques. Okay, I'm trying to integrate 2 on x. Okay, I will remember that I can move this 2 out to the front. Okay, and I know the integral of 1 on x is natural log of x, a plus c. So integrating here, in a definite sense, it'll be 2 natural log of x between 2 and 3. Okay, I'll evaluate this at 3 minus it evaluated at 2, just like all these other ones. So 2 natural log of 3 minus 2 natural log of 2. Okay, and from there I can put it in my calculator to find an approximate result. 2 times ln 3 minus 2 times ln 2, about 0.81. So I shouldn't have an equal sign there, I should have a approximately equal sign. Okay, final problem, integrating again. I know that when I integrate e to the power of anything, it'll stay the same. Okay, but I need to divide by the differentiation of what's at the top. Okay, between 0 and 6. Again, evaluate this at 6 minus the thing evaluated at 0. Okay, keep it in exact form, e to the power 12 on 2 minus, this will just end up as a half, okay, because e to the power 2 times 0 is e to the power 0, which is 1. Okay, that's what's happening in here. Okay, again, if you want, you can find an approximation. So you should be able to have a go at all of these integrals. All of these are basically C-level questions. I think I recommended that you have a go at this one, this one, this one, this one, and this one, and this one. Just a few hints on 1 or 2 of these. In I, this is actually integral between 2 and 5 of 1 dp. Okay, and for O, just do everything exactly the same, even though there's an infinite sign, and just try substitute in the infinity. We can make these problems harder by asking you to find different things. Like for example, in question 1, we ask you to find what's that end bound, okay, given that you know this area. Okay, essentially the question is, this is our graph between 0 and what value would give this area to be 4. So we wouldn't do anything different. Okay, there's no magic happening here. Okay, you're just going to do exactly the same drills. Okay, I'm still going to integrate this. Okay, between 0 and k. Evaluated at k. Okay, minus the thing evaluated at 0. Equals 4. Okay, cancel, k squared plus 3k. All of this is nothing, equals 4. This is a quadratic, which if you're in 12 Maths B, you should be pretty happy to solve. Quadratic, set it equal to 0. Factorize. And then use the null factor law. K plus 4 equals 0. K is minus 4. K minus 1 equals 0. K equals 1. Okay, so here are my two possible solutions. And this will be like a B or an A level question on an exam. Okay, so have a go at these problems, practice, make sure you check your answers with your graphics calculator, and good luck.